In section 6.6, we are dealing with function operations. The operations we're talking about here are standard four mathematical operations: addition, subtraction, multiplication, and division. So the first thing you want to really look at is the notation. Because we all know what adding, subtracting, multiplying, and dividing is, but how do we write it when we're talking about doing that to functions? If I have f plus g of x, that literally just means the f of x function plus the g of x function. And so f minus g of x is the f of x minus the g of x. F times g of x is the f of x times the g of x. And then f divided by g of x is the f of x function divided by the g of x function. We will be finding the domain of our resultant function, and when finding the domain, the resultant function has to have a domain that is in both the f and g functions. Okay, it's the overlap of the domains of those two functions. And if you're dealing with a quotient, meaning dividing, you have to be very careful because your g of x function, whatever you're dividing by, cannot equal 0. So we'll see a couple of situations there where we have to watch out what our values of x are going to be because we are dividing by that function. So let's start with an example. We'll go ahead and do just the addition part for now. So we have our two functions, f of x and g of x, and we want to add them together. So I want f plus g of x. And again, that literally means the f of x function plus the g of x function. Well, the f of x function is 4x plus 7, and our g of x function is the square root of x plus x. So, in adding these together, we need to combine any like terms that we might have. I like to put the square root at the end so it's not confusing what's under the square root and what's not. And so we have that. That's all the farther we can simplify this down. Well, now we need to find our domain. And to do that, we need to know what the domain of each function is individually. Now, as you remember, the domain is the x values, so we're asking what are the possible x values we can plug into these functions. F of x is a line that's in the form y equals mx plus b, and so there is no restriction. It is all real numbers. Any real number you can think of, we can plug it in for x and get an answer. But for g of x, we do have a restriction because we're taking the square root of x. And we know that we cannot take the square root of negative numbers, so therefore our x values can only be 0 and positive. So the domain here is going to be from 0 to infinity. It can't be negative numbers. So we got to think now, where do these two domains overlap? What numbers, another way of saying that is, what numbers are in both domains? And really, it's just that 0 to infinity, because 0 to infinity is also included in all real numbers. So the domain of our resultant function starts at 0 and goes to infinity. And please remember, I used a bracket here because 0 is included in my domain. I used a parenthesis here because we cannot actually count to infinity. There's our solution. Let's look at another example. So here we will just do the subtraction one. We have our two functions f and g. If I am subtracting, then that means I have my f of x function minus my g of x function. So the f of x function is 2x squared plus 8, but I am subtracting an entire quantity. I got to be careful. I have to put parentheses around that to show that I'm subtracting the entire quantity, x minus 3, which is my g of x function. Now I need to do that because I am subtracting x and I am subtracting a negative 3, which translates to subtracting x, but adding 3. So I've got to put the parentheses around there so that I know exactly how am I going to subtract that whole quantity. Once I have that done, I can again combine like terms. So f minus g of x equals 2x squared minus x plus 11. Well, now I need to find the domain. So again, I go back to the original functions. My f of x function is the equation of a parabola. I know that because I have an x squared up here. And parabolas have all real numbers for their domains. Okay, and again, think of it as what x values can I plug in? Well, I can plug in anything I want because I can then square it and multiply it by 2 and add 8. Similarly with g of x, my domain is going to be all real numbers. And again, because this is a line, and lines other than vertical lines, they have all real numbers for their domain. But also I can look at it as just that x variable and say, well, what number can I not subtract 3 from? Well, there isn't a number. Every single number out there I can subtract 3 from. So the domain here is all real numbers. Therefore, the domain for our resultant function, f minus g, is going to be all real numbers. And to write that in interval notation, we put a parenthesis, and we say we're going back from negative infinity all the way up to positive infinity. All right, let's do some multiplication and division. So, multiplying and dividing. First, we are going to do the multiplication. So if I want f times g of x, that means I take my f of x function times my g of x function. So the f of x function is x squared minus 9, and I'm going to multiply that by my g of x function, x plus 3. So in multiplying those two binomials, I have to FOIL, or double distribute. So I take x squared times x, which is x cubed, x squared times 3, which is 3x squared. Then I've got to take negative 9 times x, which is negative 9x, and then negative 9 times 3, negative 27. Well, there are no like terms, and it's already written in my standard form, so I can go ahead and leave that as my answer. That is f times g of x. But I need to find my domain. So the domain of the original f of x function is all real numbers. It is a parabola. Okay, so I can take any x value, square it, and then subtract 9. So that works. G of x is a line. And again, there is no number out there that I'm not able to add 3 to. So the domain is all real numbers. So since I'm multiplying here, my domain is going to be all real numbers for my resultant function. And again, the way I write that is from negative infinity to positive infinity. Now, changing a little bit here, if I go through and do the division part of this, f divided by g of x, that's going to be my f of x function divided by my g of x function. Well, the f of x function is x squared minus 9. The g of x function is x plus 3. And I need to see if I can reduce this down. Please remember, you can only cancel out factors. You cannot cancel out terms. So do not try to cancel the 9 and the 3, or the x squared and the x. You can't do that. But we can factor the top. X squared minus 9 is a difference of perfect squares, so it factors into x plus 3 times x minus 3. And on the bottom we get x plus 3. So we want to go ahead and start to cancel stuff. I can cancel the x plus 3 from top and bottom. So we now know that f divided by g of x equals x minus 3. Now to find the domain, you got to be careful, because here we're dividing. And so you look at this original, or this resultant function and say, okay, there is no denominator, and I can go ahead and plug anything in for x and subtract 3 from it. And you're right, you can. Except, to get to this stage, we had to first divide by the g of x function. And so since we had to divide by x plus 3, we've got to ask ourselves, what value of x makes x plus 3 equal to 0? So we set x plus 3 equal to 0 to find out what value of x makes that denominator 0. So we have to subtract 3 from both sides. And we find out that x equals negative 3. So that means when x equals negative 3, the denominator of this fraction is equal to 0, which means, well, we can't do that. It's undefined. So our domain can be any real number out there except negative 3. So the way we write that, in interval notation, we are starting at negative infinity, and we can go all the way up to negative 3, but negative 3 is not part of our solution set here, our domain, so therefore I use a parenthesis saying, well, it can't be the negative 3. And then the symbol I'm going to use here is a U. It stands for union. And I want to use that because I want to bring these two intervals together. I want to go from negative 3 to positive infinity. Okay? So the U for union means that I am taking the interval from negative infinity to negative 3 and the interval from negative 3 to infinity together. Okay, I want the union of those two intervals as my domain. And so then that is our final answer. All right, let's try one more example here. Look at the problem right next to it. We have our two functions, function f and g. We first, just like before, want to multiply those. So f times g of x, literally we take the f of x function and we multiply that by the g of x function. And so that means we're taking 3x squared minus 11x minus 4, and we're going to multiply that with 3x plus 1. So this is just like any other FOIL, it's just a little extended now. You take the 3x squared and you distribute that through. So that gives us 9x cubed plus 3x squared. Then you take the negative 11x and you distribute that through, giving us negative 33x squared minus 11x. And lastly, we take the negative 4 and distribute that through. So we get negative 12x minus 4. We can combine some like terms. We got a pair of like terms there and a pair of like terms there. So we get 9x cubed minus 30x squared minus 23x minus 4. There's no more like terms we can do, and so that is the result function. So f times g of x is excuse me, is 9x cubed minus 30x squared minus 23x minus 4. The domain here, again, we have to use the domains of our g and f functions. Well, f of x has a domain of all real numbers because it is a parabola, and g of x has a domain of all real numbers because we're dealing with a line. And so our result vector, or not vector, excuse me, our result function is going to have a domain of, again, all real numbers, because that's where those two overlap. So we've got to go from negative infinity to positive infinity for our domain. So now the last part here is the dividing the two functions. So if I have f over g of x, that is my f of x function divided by my g of x function, which means I have 3x squared minus 11x minus 4 over 3x plus 1. Now we need to try to reduce that fraction. And please remember, you cannot just cancel these 3's or these x's. Okay, you can only cancel factors, not terms. So we've got to try to factor this trinomial. So the way to do that is like we learned way back in Unit 1, we're going to use that x method. I'll do it up here. I take 3 times negative 4. Watch your negatives. I get negative 12. Then I want to take the negative 11 and put it down here. I'm looking for two numbers that multiply to negative 12 but add up to negative 11. That would be negative 12 and positive 1. I then rewrite that trinomial, but I tear apart the middle term and make it negative 12x and a positive 1x, because those together add up to the negative 11x. Now I can factor by grouping. So here I can factor out a 3x, leaves me with x minus 4. And in my second group, I can only factor out a positive 1, leaving me with x minus 4. So factoring out the x minus 4, I'm left with 3x plus 1. So we get x minus 4 times 3x plus 1 over 3x plus 1, which means then the 3x plus 1's can cancel. So f over g of x equals x minus 4. Now here you're going to be tempted to say that your domain is all real numbers, because you're going to think, well, the f function and the g function both have a domain of all real numbers. Or you could say, well, because I can take a number minus 4, any number in the world I can subtract 4 from, so that must be all real numbers. Okay, but the issue is that to get here, we divided by 3x plus 1. So we've got to make sure that 3x plus 1 doesn't equal 0. And the way we do that is we take that 3x plus 1 and set it equal to 0. And we solve for x. So 3x equals negative 1. Dividing both sides by 3, we find out x equals negative 1/3. So x can be any number out there, it can be all real numbers, except it cannot be negative 1/3. So to write that in interval notation, we say negative infinity to negative 1/3. It's not included in our answer, so we use a parenthesis. We're going to unite that with another interval, starting at negative 1/3 and going up to positive infinity. That is then our answer.